Left off, we had just finished greatest integer function. And remember, I just talked about when you graph that, I showed you where to find y equals int x. Well, this is a valid equation. It's not what you can type into the calculator. We have one last one, and that is called the logistic function. 1 over y equals 1 over 1 plus e to the negative x. And no, you're not supposed to know anything about that one. You need to plug it into the calculator.
Mine is not working.
What do you mean
It's not better.
No, it's rough. Yeah. It'd be better.
Then how did you get fries?
Someone help Natalie with the E.
You don't make my pumpkin.
Hey, cool it. Apparently I'm here not to win part.
Yeah, with who was it? Tracy.
Lucy. Me and Lucy were locked in.
Tracy. Yeah, I think that's what.
Okay, guys, make sure you make a fraction bar.
What is this?
1 over 1 plus e to the negative x. And graph away. Try to do 6.
That's why I told her to.
Because I couldn't see any tick marks, which means it was probably way zoomed out. So,
You did not tell me to do that.
okay, guys. What do you see?
A line.
A line?
Wait,
Not exactly a line.
Not the same.
Okay.
Regraph. It's like an opposite.
Okay, let's see how you plugged it in then.
Go
Okay, now, one thing you might want to do here to get a better view, you could do a zoom in to get a little bit better view of what's happening there up close.
Oh, I didn't put a negative.
See?
See? Look at you making all this.
Okay, guys, you can see when you zoom in there, and there we're just looking from like -2 to +2 in terms of x values. It does look like it's increasing a little bit there, yes?
Yes.
If you do a trace, okay, and if you start running right, follow those y values. I'm at 0.8 now. I'm at 0.9, 0.96,
Is it gonna land on
0.98,
the
0.99.
You're never gonna get to one.
Yeah, what are you guessing here? I mean, I'm sitting there arrowing over and over. It's not going to 1, is it? So what is happening at 1? There is an asymptote. What can you guess about at 0?
Yes.
Yeah. If you go the other way, and you start tracing the other way, guess what we're going to get close to here in the terms of the y values?
0.
You're going to get down closer and closer to 0. Now, you'll notice it's not 0 point anything anymore, but notice I'm in scientific notation, and my power on my scientific notation is growing, or shrinking, I guess. -10, -11, so I'm getting smaller and smaller decimals. So what this logistic function does is it's almost a straight line, but not. Runs along the x-axis, curves up and through a half, and then continues to run along the y-axis. So you can think invisible asymptote around 1. I'm not 100% crazy about that graph, but I don't know if that's a whole lot better, but okay. Domain. Infinitely left, infinitely right. Yes. So negative infinity, positive infinity. Range. How low is this going? How high is it going? 0 to 1. What about those parentheses? Because does it touch 0 and 1? It does not. Okay. So you have your 12 graphs. Now, there is no easy way to do this. You're just going to have to be flipping back and forth. Okay? There's no easy way to do this. In a stapled packet, even then, I would still have to, you're still going to be flipping back and forth no matter what I do. So, we are going to try some questions. Okay? So 1 through 24 in homework is 2 different matching sets, and I can address those when we get done with the notes. But they're kind of 2 different matching sets. And the idea is not to just plug everything into the calculator, but be able to look at a graph and an equation and say, oh, hey, sine x. There's a weekly one going up and down, up and down. Those probably go together. Being able to address things like that. Okay? Some of these questions here. That's an idea. Took a picture with the iPad. Has a picture of the front page of the notes. Interesting.
Caitlin said she
It could work.
tried to do it on the calculator.
Okay. Okay. Example 1. Now, I will say this is probably, in all honesty, if you ask me, this is probably one of the toughest questions on here, but it's a good question to get us thinking. Only 2 of the 12 functions have points of discontinuity. Are these points in the domain of the function? Now, the first part of this is easy. 2 of the 12 functions have points of discontinuity. So as you look here, what one?
The greatest integer function and then the reciprocal function.
Okay. Greatest integer function. Is this continuous?
Uh-oh.
No, it's a bunch of little stair steps, a bunch of little lines. Definitely not continuous. Reciprocal function. Is it continuous? Can I draw it all at one time? No. So my 2 answers there, and I can't remember how the answer key is. Whether the answer key has reciprocal or whether the answer key has y equals 1 over x. So you might kind of want to put them both. I can't really remember what I put in the answer key. And then the other one was the greatest integer function. And I tend to just write that as using the y equals int x. If you want to write it with the square brackets around x, you can write it that way. You just can't graph it that way. Now, are these points in the domain of the function?
No.
So, on the reciprocal function, first of all, where is this graph discontinuous? When x equals 0. Is 0 in the domain?
Yes.
Technically,
No.
we wrote 0, but what we put was 0. Parentheses as in 0 is not included. So, with our reciprocal function, when it says, are these points in the domain of the function? No. Okay. No. X equals 0 is not in the domain. Okay. Greatest integer function. Where is it discontinuous? Let's see. It's discontinuous at -1, it doesn't connect. At 0, it doesn't connect. X equals 1 doesn't connect. X equals 2 doesn't connect. So it's discontinuous lots of places, yes? Are those values in the domain? What is my domain? Negative infinity. So every place is discontinuous. This time, those values are in the domain. Okay, so the question I'm answering, only 2 of the 12 functions have points of discontinuity. This one had x equals 0. X equals 0 was not one of the numbers listed in our domain. Now, greatest integer function, it's discontinuous at every integer, yes? Are those values in the domain, though? My domain was -infinity to +infinity. So when it says, are those points in the domain? Yes, those points are included in the domain. So I'm going to say discontinuous at every integer value, and those values are a part of the domain. Most of the time on the homework, there's not explanation. This is kind of an oddball question compared to most of the time you'll just get to list which functions answer the question. For instance, the next one. Don't say anything out loud yet, but start thinking about question 2 when you're ready. Only 3 of the 12 basic functions are bounded. That is both above and below. Which 3? So there's no other question to answer. There's no explanation. I'm just look through those graphs. Bounded above and below. So they don't go infinitely up. They don't go infinitely down. They have a set height and a set, what's the opposite of height? Bottom value. They don't go past. Okay? Give me one, Autumn. Let me think about sign. Because it always stays between -1 and 1, right? Now, again, you could write sign, which is the name of it, or you can write the equation. I think in homework I put more equations, but I don't remember. What's another one? If sine is bounded, then cosine is bounded. So cosine, or y equals cos x. Said 3, I need one more. No? It's going to keep, even though it's those lines, we're going to keep having more and more of those little lines.
Logistic?
What about logistic? Look at the range.
Would it be 0?
Oh.
Because the range on logistic is 0 to 1. It has a set lower and set upper part, doesn't it? If you go through and look at all these other ranges, all the other ranges have infinity somewhere. Or all integers on the one. But all these others have infinity on one end or the other of the range. So your other is the logistic, which is y equals 1 over 1 plus e to the negative x. Start memorizing those names and equations. Okay? Getting familiar with those. Okay, ready for example 3? 3 of the 12 basic functions are even. Which are they?
Square root function. It looks
Even. I think I have to disagree with square root function.
square. It only has even.
Squaring function. What about the squaring function?
But it goes to negative.
Okay, hold on.
Is it like the graph is even on both sides? Like
Okay, yeah. We need to go back to lesson 1.2 and review the definition of even, which I think is probably 1.2 part 2 maybe. Definition of even is going to make this a lot easier to answer the question. Autumn said something about,
even across the axis.
yeah. So officially she's saying even across the axis and drawing a picture in the air. The official wording is symmetric across the y-axis, because what did odd mean? Symmetric across the,
X.
not x,
Why?
the origin.
Oh, yes.
We've definitely forgotten, haven't we?
Yep.
Okay, so odd was symmetric across the origin, even was symmetric across the y-axis. Or algebraically, this was f of x equals f of negative x. Okay? So, now, are we okay with why I vetoed Emma's square root function then?
Yes.
Okay? Because this square root function, whoops, I can't fold it in half. Are we okay with the squaring function? Y equals x squared.
Yes.
Yeah, I fold a parabola in half, and it is symmetric. I need two more. Stetson, what's one?
Absolute value function.
Okay. Absolute value function. Can I fold that v in half and it's the same both sides? Okay, there's two.
The sign.
Don't even
Okay. I've heard so many different options here. Reciprocal, I'm vetoing because it's not, I can't fold it at the y-axis and then land on top of each other. Identity, vetoing for the same reason. Now, these might fall into the odd category, but I'm not asking odd. I need symmetric across the y. There is a third.
Sign.
Not sine,
Cosine.
cosine. Okay, now, why not sine? Right there, if I fold it, it goes through 0, 0, so we have, you're going to fold a mountain on top of a valley. But, what do you notice about cosine?
It doesn't.
Yeah, it goes through 1, and it's at the top of the mountain is where we would fold it. Okay, so, we said squaring is one of the names. What's the equation for that? Y equals x squared. We said absolute value, which is y equals absolute value of x. And we said cosine, which is y equals cosine of x. Okay. Some of this is the type of questions you're going to have to answer, okay? So hopefully we're starting to catch on a little bit.
These
Now,
simple. There's no like math.
which is good and bad.
It's magic.
It's good and bad.
I can definitely.
Okay. Example 4. Okay. It's going to ask us some questions about example 4. Now, it says graph this. Let's use our brains for a moment. Because we don't need the calculators for this one. We don't need the
Yeah,
calculators for
because
this
you're
one.
going to go down
That's a
2,
parabola.
and it's a parabola.
I half agree with what he said.
It's gonna go right to.
No, it's going down. Rock, paper, scissors.
Right. But up. If it's in the parentheses, it's opposite
Is
side.
it going
Oh,
down?
she's so right. No, it's going left. No, it's going right.
If it's in the parentheses, it's opposite signs going left or right.
You got
Oh, shit.
You got it.
So, it is a parabola.
You were in the ball.
We got that from the beginning. We knew it moved to some direction or another. It's just I think we said all 4 directions before we were done with it. Okay, so this is a parabola moved to right. So with that in mind, 1, 2, and that's good enough information for me. Okay, it doesn't have to get more specific than that. Now, on what interval is the function increasing? And then we'll answer decreasing.
2,
Or whichever way, but
2 infinity.
is what?
Increasing.
Okay, so if we start down here at the bottom at the vertex, yes? We are starting to increase at the ordered pair to 0. And so we start increasing at 2, and we're increasing to infinity. I say, we've been using brackets, right? Okay. So that is your increasing. What's that mean about the other half?
Decreasing.
Negative infinity.
Okay. So as we move left to right, we're moving from positive infinity to 2, and we are decreasing. Or excuse me, negative infinity
Oh my gosh.
to 2. I think I said positive infinity in there, didn't I? Because you're moving from the left. You're moving from the left to the right. Negative infinity to 2. Okay. Is this function even, odd, or neither? Is it symmetric across the y-axis? No, so it's not even. Is it symmetric across the origin? No, it doesn't have a diagonal symmetry. So it is neither. That's come back a little bit better now that we talked about it, I take it? Okay. Does the function have any extrema? No, extrema.
No extrema.
I didn't get the typo corrected in here, I know, because my notes are wrong too. So that is supposed to say extrema.
What does it say?
Oh, it doesn't. Oh, because there's an R.
Aren't you guys missing an R?
Yeah.
Because my notes are missing an R too. I caught it when I was doing my answer key here. So,
Don't worry about it.
okay. You guys remember what extrema are?
Mins and max.
So really what this question is asking is, does this function have any mins and maxes? As a min? Where?
2.
2 what? Yeah. There's a min at the ordered pair, 2, 0.
No max.
No max.
Because
Because it's going infinitely up. Okay. What'd you say?
Absolute.
Well, it technically is both. It's absolute, though, because that is the lowest point the graph will ever go to. It is a local just because all max and mins are considered local. How does this graph relate to the basic function y equals x squared? Yeah. So what's the transformation here? The fact Kay used the word shifted, I'm going to use the word translate. So translates right to units. Okay. You're going to see there's either 1 or 2 questions like this. I can't remember if it's 34 and 35 or 38 and 39, or like what we just did there with example. Okay. Example 5. 2 of the basic functions have vertical asymptotes at x equals 0. Which 2?
Squaring and absolute value. I'm gonna fill logistic and logistic and reciprocal. Oh, asymptote. Are those horizontal? Are those horizontal?
Hold up.
I got
Wait.
You guys.
reciprocal and
Natural logarithm.
what? I agree.
Okay. I've heard reciprocal a couple of times.
Oh yeah, you're so right. Vertical's up and down.
Okay. Okay. Is that what we need to review here? What vertical is? Okay. So, vertical asymptotes at x equals 0 is, where is the y-axis a vertical asymptote? So, I heard reciprocal. That one definitely has a vertical asymptote, didn't we? Now I'm realizing she was referring to it as a horizontal at the time, but okay. So reciprocal, yes? What else?
Natural logarithm.
We're looking for vertical. Natural log? Okay. So natural logarithm.
For the test, am I gonna have to know all these? Like what they look like?
Yes and no. I'll address that at the end, unless I say no calculators.
Okay.
But I don't, so I'll address that here in a moment.
Okay.
Okay, are you guys okay with part A?
Yes.
Because now we get to do part B, which says 3 of them have
Oh no.
horizontal asymptotes.
Is both of natural logarithm
Reciprocal.
or reciprocal? Reciprocal.
Yes.
Okay, does reciprocal get to count again?
Yeah.
Reciprocal gets to count again. So reciprocal
Logistic and exponential.
Reciprocal is y equals 1 over x.
Which one did you say?
Logistic.
Oh, exponential, yeah.
Logistic, the one we just graphed today.
Yep.
That has a horizontal asymptote underneath, doesn't it?
Yep.
And that is y equals 1 over 1 plus e to the negative x. And, someone said the other one,
Exponential.
exponential.
Units. Not even a weapon. I did units. I was really.
Okay, are we good?
Great.
Now. Last question. Does the graph of y equal ln x have a horizontal asymptote?
Yes.
No.
I'm just saying yes.
It's
Yes.
increasing.
Which one was it? ln x?
Yeah.
Okay. So the question is, does it have a horizontal asymptote? Is there a spot where it levels out over up here?
No.
And no. Our domain or our range shows us going up to positive infinity.
My fault, guys.
Okay. If you have not written the homework down, write it down. Page 103. Gosh darn it. That's going to be rough.
Just kidding. It's gonna vote for Friday.
One through 24, 29, 30,
See, you see how much?
34, 35,
38, 39.
38, 39,
Are we doing
41.
these?
Nope.
Oh.
Huh?